Welcome back to Learning with me, Ms. Killen, here at MPB. I'm so glad that you came back. We're still in our 9th unit. We are still looking at functions. We've looked at linear, we've looked at quadratic, we looked at exponential. We've just now learned piecewise. So now we're looking at polynomial functions. So let's go ahead and look. Polynomial functions graph an ending behavior. I can graph polynomials. We're looking at F-IF.2 and BF3. So let's go ahead and dive in and see what we've got. So obviously we're looking at quadratics. We can see that by the parabola. So let's look at these. I have y equals x squared where my parabola opens up, and then the reflection of that when we talked about transformation is y equals negative x squared where my parabola opens down. So you really have to look at our equations to see what we're doing from the parent function. Now we've talked about parent functions, where it all begins, and where it all begins we go from there, and that's the different transformations. So let's look. Okay, our ending behaviors for these different ones. So let's go back to the parent function, y equals x squared. As my x's increase, my y values increase. As my x values decrease over here on the left, my y values are increasing. Now, when we flip that or reflect that, we've got a different set of ending behaviors. So let's look at these. So when my y value over here on my reflection increases, when my x's increase, my y's are decreasing. And then again, when my x's are decreasing, my y's are also decreasing. So you've got to make sure that you're looking at these different endings and the behaviors of these endings to see what you've got in these different polynomials. So let's see. All right, as x increases, y increases. As x decreases, y decreases. This is our exponential function. We have y equals x cubed, and that is a perfect example of an exponential function. So then we have the opposite behaviors when we do a reflection, which is a different type of transformation. We're just reflecting it. So when we have y equals negative x cubed, I have a different looking graph. So let's go back and look. There's our original, our parent function, and then there's a reflection. Can you see the difference? Okay, so in our parent function, as my y's increased, meaning going up, so did my y's. My y increased and my x increased. And then as my x's decreased, my y's decreased. But let's look at the reflection. So with the reflection, as my x's increase, meaning going this way, my y's are decreasing in their values. But when my x's are decreasing, meaning going this way, my y's are increasing. So we have to make sure when we do these different transformations, these reflections in specific, we've got to look at those ending behaviors. All right, now that we have seen what the behaviors are, let's learn about how to write it as an ending behavior, because there's a specific way that we're writing. Now, while we're at this page, I want us to write a note, okay? Either on your notes page or where you're taking notes, I want us to put something down which is noteworthy. So I'm going to put it on the board. Here we go. So, in ending behaviors, it means approaches a value. And we also need to take note of arrow notation. Ms. Killen, you keep telling us about all these different types of notations. I do, because all of that helps us understand and make sense of the math. So we have all these different types of notations. Now we have arrow notation. And can you guess what is an arrow notation? An arrow. All right, so let's look at this. Use f of x equals x squared. Tell what you notice. Now we're going to write those ending behaviors. So first, let's see what we notice. So as I'm looking at this and I start at my y-axis, I notice as my x's increase in value, what does my y's do? So let's get a different color so we can see this. Let's do red. Okay, so as my x's grow larger, so does my y values. So as x increase, y increases. So then what about if we go the other way? So let's go back and see. If we go the other way, let's get blue. As my x's decrease, so as x decreases, what happens to y? We're going to say y does what? It increases. So for me to write this ending behavior in arrow notation, I'm going to use an arrow. So watch this. So I have as x approaches positive infinity, my f of x or my y values also approach positive infinity, or they're increasing. So then let's flip it and say as my x approaches negative infinity or decreases, my y values or my f of x approach positive infinity, which is increasing. So this is my arrow notation. That arrow notation means it's approaching. So sometimes they're going to approach one but never hit one. So that's what these arrow notations are telling us. It's approaching. All right, so here we go. Let's look some more. So this is the reflection. What would be the equation? What do we notice about the information in the graph? Write the ending behaviors. Now, for me to look and compare the reflection, I need to go back to the original or the parent function. So the apparent function was f of x equals x squared. So if it's reflected, I would say it's what? Yes, I could say it's f of x equals negative x squared. So then let's go ahead and write these ending behaviors. Let's get a different color. Let's use orange. All right, so I'm going to say as my x's approach. Now, as my x's are getting bigger in their values, they're going to the right. They approach positive infinity. What happens to my y values? They are going what? They're lowering or decreasing their value. So my f of x or my y values are approaching negative infinity. Because remember, this is negative infinity, this is positive infinity. This is positive infinity, this is negative infinity. And sometimes you may have to write those symbols on your graph so you know, am I going to positive infinity? Am I going to negative infinity? I mean, what am I doing? So sometimes it's okay to write those. I do it. I have to because I want to make sure I'm keeping the math correct. All right, so then let's go the other way. So here we go. Let me get a different color. So then as my x's approach negative infinity, or I'm going left, my f of x or my y's approach what? Yes, negative infinity. So we've got to make sure that we're understanding what my x's are doing to determine what my y's are doing. Good job. All right, so let's graph both of these. All right, so I'm going to use these two colors. While I graph up here, you graph on your paper or your notes page and let's compare. So here we go. Let me get the blue. So my blue graph is going to look like, and remember Ms. Killen cannot draw a straight line to save her life, so please take this in consideration. So then I've got my reflection, which is, there we go. So we've graphed them. And when we look at these, I have a reflection over my origin. Okay? So I just reflected. Good job. So obviously I did not draw it as spectacular as this one, but you can see what it would look like. My y goes up and up, my y's go down and down, depending on if I have the reflection or the parent function. So, read the equation. Look for all information you can get from the equation. Graph on Desmos or your calculator. Write the ending behavior. It's time for you to master. So go ahead, you do this on your paper, either you or you and your table partner, and then come back to me and let's see what we got. All right, so what I'm going to do is I'm going to plug this in and see exactly what it looks like. So here we go. So I'm putting it in Desmos, and I'm going to put y equals, and then I have negative x to the fourth. I'm going to scroll over to get out of my exponent, and then I have plus 2x plus 13. Now, Ms. Killen, that looks like a parabola, but does it though? Oh, no, it does not. Because we're going up, now we're going over, and then we're coming back down. So where it may look like a parabola, it's not exactly a parabola. So you got to make sure. So let's go back and see what they want us to do. Now I graphed it, I looked at my equation, now I'm going to write my ending behavior. So let's go ahead and do this. Let me grab a color that will, all right, so here we go. So as x approaches my positive infinity, okay, so here's where it was. Don't worry about the bumps. We're just looking at the ending behaviors. So remember, this is positive infinity, this is negative infinity, this is negative infinity, this is positive infinity. So as x approaches positive infinity, what are those y values doing? They're approaching negative infinity. So then as my x approaches negative infinity, what are my y's doing? Yep, they're approaching the negative infinity. So you've got to make sure that you're understanding we're using our x values of what they're doing to determine what my y values are doing. Good job. We don't want to forget how we read these graphs and these equations, how we write the ending behaviors, that new notation that we learned. We don't want to forget it. And what happens when we do the reflection. All right? So we got to make sure that we are looking at all of these and we're making sense of these new terms and these new formulas that we're getting. We want to make sure that we're keeping notes of these. I'm so glad that you came to join me here at MPB. I'm so glad that you're learning with me. We're almost at the end of Unit 9, so make sure that you're taking notes and you're practicing. I want you to have a great day.